Okay, now to our dependencies. Our dependency list is kind of puny right now. We're not going to get very far if we have nothing but Ruby. I'm not going to make you guys sit through typing all this out because I have cheat sheets. There's our dependency. So we've got some Jersey stuff there, Spock, test framework, the Jersey test framework, and a little bit of magic that we'll get into later. Anybody know Lombok? One, two, okay, cool. Do that in a little while. Now,
scroll to the far right.
Now here you see one of the strengths or weaknesses of Gradle, depending on your perspective, right up in this vicinity. With Maven, you would only have to list Jersey server and Jersey client. You use the server and the client. This is the transitive dependency of server, and this is the transitive dependency of client and server. Gradle, however, has a rule for their dependency resolution. You're only allowed to compile against first level dependencies. That's these listed right here. You cannot write code against the transitive dependency. At runtime, you get all transitive dependencies, just like Maven, Ivy, whatever. They do that to make you be a little more disciplined and be a little more aware of what exactly you're writing code against. So I haven't really decided where I fall on that. I kind of like the extra rigor of having to list it out, but on the other hand, you get like twice as many things as you need to, or I guess as you're used to seeing, like in Maven. So take that to work for. Now, in another departure,
we give you warnings if you're no longer using one of these.
I don't know how to give you a warning, but you can run analyses to find dependencies that aren't used. But of course, in Java, that's always dangerous because just by virtue of having something on the class path, it can change behavior, even if you're not necessarily directly using any of those classes. Blah, blah, blah. We'll do that if something we get there. All right. Another departure from standard Maven and Ivy is Gradle doesn't have a default repository. It has no idea where you get artifacts from, so we have to tell it. However, it doesn't make it very simple. Still do it? Okay, thank you. There we go. Maven Central. That's just a built-in method. It knows where to go from Maven Central. Makes it really easy to remember. You don't have to type out that stupid URL every time. And finally, while Sublime is pretty awesome, that's the text editor, which, if you guys don't know about this, is a TextMate clone cross-platform. Very awesome. I highly recommend it for text editing and basic scripty stuff. Also compatible with all the TextMate bundles, is what they call them. So basically anything that you can do in TextMate, you can do in bundle. However, we want to move into IntelliJ. I want to move into IntelliJ. How many IntelliJ users? So everybody else is clipped? I'm sorry. Okay, so now we've got IntelliJ support. I'll save that. And that's our build script. Pretty light. To be fair, a Maven POM of the same content wouldn't be that much bigger except for the dependency section. But, this is pretty basic. You guys familiar with Spring integration? The enterprise integration patterns in Spring with JMS and Speed and all these different endpoints. That project is built with Gradle. I just cloned it the other day to check out some of the code and make some modifications. Their entire project is defined in one Gradle script, which is, I believe, 1,200 lines long. And 900 of those lines are sentences. So the entire thing, and that thing has at least 20 modules, probably upwards of 30. All in that, like 300 lines plus sentences. It's pretty incredible. That is what Gradle gives you. Okay, done with that for now. Now, sadly, Gradle does not have a built-in way to generate project structures, kind of like Maven archetype, which I don't really like Maven archetypes, but it would be nice if there were a way to at least say, generate me the basic project directory. Gradle doesn't have that. There's an open issue for it. And there is a pretty extensive third-party library or third-party plugin to Gradle for doing it. But we don't need to get into all that. All we need are a couple of source directories. We'll do a source main Java. It's worth pointing out that all of my main source for this presentation is going to be strict Java. No Groovy in main source. The only Groovy is Gradle and testing. We only use Groovy for testing. Main source is pure Java. So you can go back to work and say, hey, that's a great idea. Everything will be Java. Everything will be fine. But I want to test this other one. So it works. So there's our main source directory, and that's Groovy. I like that. So we have our source directory over there, and Gradle idea, and that'll bootstrap our LJ project for us. While that's going, so Gradle has really good idea support and Eclipse support. You can generate projects straight out of Gradle really easily. IntelliJ has strong support for Gradle, I would say, and it is improving. I expect big things from their version 4 release, which should be next month. Eclipse, I'm sorry to say, I can't really speak to. No, I'm not sorry to say. I actively shun Eclipse at every turn. It's just more trouble than support. So I can't really tell you how the state of Gradle is with Eclipse. So that should get a start over here. You can go and open the project. So I created a little IntelliJ project file for us there. Open it up. And there's our source directory. All ready to go. There we are. Ready to develop a web service. Got the icky stuff out of the way. Build's all set up. I have prescient knowledge of all the dependencies that we'll need ahead of time, so you don't have to worry about wading through all of the class unbounded tests and all that. It's just going to work. Of course, we haven't really talked about what the service is going to be. Because I'm running this thing, and I've practiced it several times already, it's going to be a user service. Because everybody knows what a user is. Everybody kind of conceptually understands what a user service would be for storing users of whatever application. Really the concept of graph. So I'm going to go ahead and get started by defining in our main source a user, which again, pure Java. This is a Java class, which is going to be, it'll have a name, maybe some roles to make it interesting. Okay, and a little helper method here, make our test a little more readable when we get to this. Oh, there's a user. And a long block annotation. You'll see what it does for us a little bit later on. Okay, now, just take a slight detour here, and before we get into the test, remember that in REST, everything has to have an identifier. So this user, every user that we create, there has to be an identifier in the form of that URI, right? That's what we said our identifiers were, what we're going to use. So when you take a minute to consider what the user's identifier would look like, it would be some server, some host, some port, no support, right? And user or users. I usually use singular. A lot of people use plural. The idea is you have a base URL. You maybe have a context in here like my app or my API. And then all users live at users, right? That's your collection identifier. That's where all users live in this system. And if that is our collection, then a specific user would live here. Right? Everybody with it. It's very important. Because if you don't get this, right now, you're going to have a hard time following the test. What I'm doing in the test. Okay. Pretty easy. Just want to make sure that everybody's got it down. Also at this point, we can discuss where this comes from. That obviously is supposed to be some kind of identifier for the user, that 1, 2, 3. So that should probably be in the user somewhere. Now, for this example, I'm just going to use the username. This would be like user Bob. In the real world, of course, you would never, ever, ever, ever do that. Ever. If you do, I might fly back up here and feature the back. Never, ever use a piece of business logic, meaningful business data, as any kind of identifier, unique key, anything like that. Same way you always generate a primary key, surrogate primary key for the database. You want some kind of surrogate key for your users in a RESTful setting. You would never expose a piece of data as the key for a user in the URI like that. But I'm going to, because as an example, that's my world and I can do anything I want. It's just for simplicity. So if you don't know why not to do that, I see lots of heads nodding around here. Just find somebody who nodded and ask them why you would do that. Because they felt that pain.